I'm recording. I got to get a new battery. Okay, so polynomials. Add or subtract. If you add or subtract polynomials, they need to be the same. Easy example. If I have a 3x plus a 2y plus 5 plus another polynomial, 4x plus 3y minus 10, you just add x's with x's, y's with y's, and then the integers. Now, this is Algebra 2. A visual of this, and you don't need to write this down. Please, you don't need to write this down. But if there's a bag, don't write this down. But in the bag, how many x's do you see?
3.
Right? So that's why we write like this, right? In the bag, how many y's do you see?
2.
That's why we write like this, because it's kind of a pain. And then these are little dots. And how many little dots do you see?
6.
So then in my other bag, right, again, you don't need to write this down. I'll make that plus. How many x's? So 4 x's. I mean, obviously that's why we write it like this, because that would be a pain to do every time. You guys agree? And how many y's?
3.
Yep. And then 10 little dots. I changed that to plus, by the way, so I didn't want negative dots. 5, 6, 7, 8, 9, 10. So if we dump them all out, put them all on the floor, we would have 7 x's, right? Plus 5 y's plus 15 dots, right? So that's a visual of something we know how to do. It's just a real simple visual, just in case you never quite understood what it meant. But I would never do this. You guys agree? If the bag's kind of a pain, I would just go straight to 7x, 5y, plus 15, right? Okay, now, example 2, if I had a 3x y squared plus 4x squared y plus a 2xy plus a 3xy squared. Okay, go ahead and write that down. I've got a 3xy squared plus a 4x squared y plus a 2xy plus a 2xy squared. These two are the same, right? But they're not. This one's different. This one's different. Yeah, this one's an x squared y. It's a different one, right? So you put together, again, we combine the ones that are the same. These two go together, right? So we have a 6. Now be careful. 6 whatses. I'm going to say it just like that. I'm going to use poor English. I'm not an English teacher. 6 whatses. xy squareds, right? xy squareds. Everybody agree with that?
Yeah.
Not x squared y to the 4th. We're just adding. How many x y squareds we have? We have 6 x y squareds, right? I've got 4 x squared y's, but that's all. That's all. So in the bag, we'd still have 4x squared y's, and in the bag, we'd have 2 of these, 2 of the xy's. And if you can't combine what we call like terms, you're done. You're done. Okay? Now, if we subtract them, it's the same process. Except we have to be careful of negatives. Okay? If we subtract them, it's the same process. We just have to be careful of negatives. Okay? Let me turn the page. Slow me down if you guys don't get it. I'm trying to watch my note takers, so if I go too fast, slow me down, okay? Also, what Peyton does, and everybody else is welcome to do this, Peyton doesn't take notes. She listens, and at the end of the period, she takes pictures of my notes. If that's the kind of learner you are, you can do that, okay? It just depends on who you are. All right, turn the page. Okay, now example 3. Subtraction is the same process, except for we have to be careful. Subtraction. I've got a 5x squared minus a 4x minus 3 minus a 2x squared plus a 7x minus 2. Okay? You got to be careful. Well, I do see for sure that these two are the same, so I can subtract those two, right? 5x squared, subtract 2x squared is 3x squared. Now, everybody listen. I need your ears. I need your ears and your eyes. I need your ears. Everybody listening? I'm going to go negative 4x, subtract 7x. I'm going to go negative 4x, subtract 7x. I'm going to get negative 11x. Okay. I'm going to show another way for those kids who get confused. There is an invisible one. You are so smart. So these two go together, and I get negative 4 subtract 7x, and I get a negative 11x. Okay. Again, give me your ears and eyes and watch. Negative 3 subtract a negative 2 is a negative 1. Negative 3 subtract a negative 2 is a negative 1. Negative 3 subtract a negative 2 is a positive 1 because you're going to subtract a negative, okay? Okay. Now, I got another way to do this that might help you. So I got a negative 1. Or, I heard Julian said there's an invisible 1 right here. Everybody agree with that?
That was Sean.
That was Sean. Thanks, Sean. And one way it's a little bit more work, but you can first distribute the negative 1 through before you add. So now instead of subtracting, I'm adding. And this will work the same way, so you don't make mistakes. Now you can definitely see the negative 1, can't you? You can see the negative 11, right? And so you don't have to do it this way. I mean, if your brain is so gigantic that you could just do this, awesome. But that's a nice way to do it so you don't make a mistake. You guys agree? Okay.
Oh, yeah.
Now, we can also multiply polynomials. So, we did this little example before where we had our 2x plus 1 times a 3x minus 5, right? We did that in a warm-up. That's multiply. So, again, side by side. Side by side. Oh my goodness, you do know what you're doing and you are smart, but too often kids will try and foil this. Well, what's that say?
Minus.
Right? And then it's a common mistake. There's no times sign here, is there? I just put it in there. It's invisible. But definitely when you get two together, you know it's multiply. So this one's multiply, and this is definitely add, okay? It's a very common mistake. You do the right process for the wrong problem, and then you get it wrong. Okay, so this is just distributive property. 2x times 3x, 2x times 5, 6x squared minus 10x. Distribute 1 times 3x, 1 times negative 5, positive 3x minus 5. If you can combine any like terms, we're going to do it. We're going to get a 6x squared minus 7x minus 5. Over here it's totally different because of the plus. Totally different because of the plus. We're just going to add. And I'm probably going too fast, aren't I? So I'll slow down for a second. This one has a plus sign, right? 5x minus 4. That's all. 5x minus 4. That's all. 5x minus 4. Totally different problem because of the operation, right? How am I doing? Thumbs up? Okay, hold on. Somebody is, huh? Hello?
Sean.
Yes.
What? Mine? Me?
The office, yeah. Okay, all right. Example 5. Okay, so example 5. I could do a 2x plus 3 times a 3x squared minus 4x plus 5. Okay, now we're in Algebra 2. This is Algebra 2. Let's do some big problems. Let's flex those brain muscles, huh?
Oh, I need more. I remember this.
This is Algebra 2. Let's flex some muscles, huh?
Cube.
Right, right. Cubed is correct. So we're going to distribute 2x to 3x squared. We'll distribute 2x to negative 4x. And we'll distribute 2x to 5. And then we'll do the 3. But let's do the 2x first. So 2x times 3x squared is a 6x cubed. Because I've got x and 2 more, okay? 2x times a negative 4x is a negative 8x squared. Okay? We have a 2x times a 5 is a positive 10x. Okay, thumbs up so far? Thumbs up so far? Okay, so then I want to distribute the 3. Okay? So, 3 times 3x squared is a 9x squared. Now watch. I like to put it right there. Why would I put it right there?
Because it lines up.
Yeah. I mean, I could put it over here, but it's probably easier if I line them up. I'm going to get a negative 12x. I'll line it up like Lexi said. And then I'll get a 15. So then when I combine like terms by lining them up, right, Lexi? It's easy. There they are. So I can combine 6x cubed plus 1x squared minus 2x plus 15. How am I doing? Okay. I saw 2 thumbs up. 3, 4, thumbs up. Okay, 5, 6, good. I mean, most of this is a review from last year, isn't it? Yeah. Okay, last problem. Last problem. Okay, I'm going to shift my paper because I'm running out of room. Last problem. I have a 2x plus 1 times a 3x minus 4 times an x plus 5. Okay? So, reach the board because it's that's okay. I'll give it back to you. So, listen real quickly. Just don't write this down. Don't write this down. Okay? You could go 3 times 2 is 6 times 4, right? You could go 3 times 2 is 4 is 8. You could, right? You get the same answer. I'm going to suggest in this case, because I think it's going to be easier, that you do these 2 first. Okay? Okay? It's going to be easier. You don't have to take my word for it, but if we do those 2 first, then it's going to be like the problem we just did. Okay? So I'm going to ignore the 2x plus 1. You could do it different. You don't have to do it my way. But I'm going to do these 2 first and ignore my 2x plus 1. So I'll bring down my 2x plus 1 and I'll just ignore it. 2x plus 1 times. Okay, you ready? All right, so we're going to distribute. 3x times x, 3x times 5.
Oh, I see.
3x times x is a 3x squared. 3x times 5 is a positive 15x. And then I'll distribute the negative 4. I'll go negative 4 times x and negative 4x. And negative 4 times 5 is a negative 20, okay? I'm going to tidy it up a little bit, but I'm getting there, okay? I'm going to tidy it up a little bit, okay? So I'm going to go ahead and I'm going to rewrite this as 3x squared plus 11x minus 20. And now I want to bring down the 2x plus 1. So we did a problem just like that in our example 5, right? So the reason I like to do these two first is because it sets us up with this kind of problem. All right, so here we go. 2x times a 3x squared. 2x times an 11x, and 2x times a negative 20. All right, I'm going to distribute 6x cubed plus 22x squared minus 40x. And then 1 times 3x squared, 1 times 11x, and 1 times negative 20. 1 times 3x squared is a positive 3x squared. Like Lexi said, line them up. 1 times 11x is a positive 11x. Line them up. 1 times a negative 20 is a negative 20. Combine like terms. 6x cubed plus 25x squared. Minus 29, is that right, Julian? 29x minus 20. All right. So what do you think? Not too bad?
Not too bad.
Okay, let me stop the video and I'll pass out the homework. Come on, stop.